Hello guys, I think I am audible now. Yeah, so today is the day 3 or we can say lecture 3 of NLP. Basically, I have doing this lecture 3 after a week. Sorry for this. Now let's continue. It's been 5 days gap, no problem. Let's continue our NLP project, like NLP related problems. We have done like all of this text pre-processing and everything, and also we have done RTF IDF, time frequency inverse document frequency. And now let's today we are talking about bird embeddings. So what is bird embeddings and all of this? So basically, in natural language processing, bird embedding is a term used for the presentation of bird to text analysis, typically in the form of real valued vector that encode the meaning of a bird, such that the birds that are closer in vector space are expected to similar in meaning. Yeah, so let's discuss like how this will work. So if you have a bird like happy and a bird also angry, so basically these birds are opposite to each other, like angry and happy. So we want something so that we can, in vector space we can also create something so that these are very far each other, so we are able to know that yeah, these are like opposite to each other. So bird embedding is the solution all of this. So like how, like we will see that. So in count of frequency we have one hot encoding, bird to back, TF-IDF we have done. Now in deep learning for train model we have used a bird embedding techniques. So in bird embedding we have continuous back of bird and skip gram. Let's see what is continuous back of birds and skip grams. So bird to back or feature representation. Yeah, so that this is the same, we can say a same meaning according to this bird embedding. Bird to back is a technique for natural language processing published in 2013. Basically, it is launched by Google in 2013. The bird to back algorithm used a neural network model to learn bird association from a large corpus of text. Once trained, such a model can detect synonyms, word, and suggest. Basically, this will what I have to say that ki if we train a model on bird embedding, this model is very good. Like this model will can think like a human. So if you say we have a bird like a king and a queen, so our model will now able to predict that this is related to a king and a queen and they are opposite to each other. So suppose if you want to create a embedding of gender, then gender embedding will be created like this. On every embedding vector, like a value will be ranges from -1 to 1. Basically we can see that how this will be represented. The first, the bird embedding is launched by Google basically. So they have represented gender something like that, like boy have they given a -1 and girl have given a 1 number, king have given a -0.92 and queen have given a 0.93, something like that. Basically these are assumptions values and assumptions, or we can say good engineers have given us something like number, so that if you provide a gender to this model and a royal, then this will be a something relation between that. If they are opposite to each other, then the distance between these two vectors are very far to each other, and if they are synonyms, or we can say a similar bird, then the distance of these vectors will be a minimum as far as can possible. So this is basically we can say a 300 dimension vector they have created at the first in 2013, but now we can see a 2480 like 2480 dimension vectors are now created for every birds. At the initial stage they have created only 300 dimension, or they have created these all of these bird train on a Google News data set basically at the time of 2013, but now we can see a very high dimension vector like 2480 dimension vectors. Now we can see that, and these basically perform very well. So like if you provide to this model like king minus boy plus queen, the model will now able to predict like yeah, you are talking about girl. So if you have a king and if you subtract from the boy and add it to the queen, so what will you will get a girl. Everyone can, like if you have a king minus boy plus queen, this will be a girl. Everyone can see that. So this is how the model will be working. So suppose this is some assumption values for the king. This is your, suppose your dimension vector 0.95 comma 0.96, and men have given something like that. So if you will do a calculation on this vector, you will get a woman vector and closely related to woman vector. So you can see that, yeah, this is your vector. That's how embedding will work. Embedding is a very very good techniques nowadays in NLP. So like now you have see that a chat GPT, BERT, and every model, like you have now see that every model is basically built train on a BERT embedding basically. And BERT embedding nowadays is very powerful. If you do a calculation on this vector and apply in the real world in English, you will get a same answer. So scientists, what they have done, they have basically converted a English vector into a math, so that the representation of a English, like a gender is English bird. So basically what the problem is, like computer will not know the English, so scientist will want something so that a model will can understand, or model will understand only numerical values. So they have converted every words into a vector so that model can understand. This is the basically a problem and a solution of that. The problem is basically computer can't understand English, so they want something so that a numerical vector which can be understood by computers. So they have converted every words of this English dictionary to something, some vectors. So the vectors will be now able to understand by models, or we can say a machine learning model, so that this can be trained, or algorithm we can create something like that. So that's how. So this is the, if you find a similarity between two vectors, if you have a angry and a something like hungry, then these birds are basically similar to each other, or the like distance of these two birds will be closer to each other because they are similar in space. If you have a bird like a movie, suppose you have created a model which can basically suggest a movie according to this. Suppose you have a Amazon Prime Video subscription, there is there. If you watch a Avenger movie, then the model will predict it, like, yeah, you can also watch Iron Man. Suggestion will become. So basically the suggestion will become on the basis of distance, or because a similar movie. If you have, this movie is basically there to, we can say, a romantic or something like that. So this movie can't suggest if you watch a Avenger movie. So that's how this will work. The distance is very very far. If you provide another vector, or we can say if you have a here a vector of happy, then here you can find a vector of like angry. The distance is very very far. If you provide an opposite word, if the bird is similar, then the distance will be minimum as possible as can. That's how this embedding is work. And here we can see only 2 and 3 dimensions, so we can see that. But the Google at the time of 2013, they have created a 300 dimension. Even you can't imagine like how 300 dimension will look like every bird have a dimension. And nowadays, like, we have a 2480 dimension vectors. Like how this is looking like, even you can't, we can't imagine, like, but the computers can imagine. So that's how they are creating and all of this. And this is the formula, like you have, you can find out like how they are similar. Like the formula is distance is equal to 1 minus cosine similarity. And cosine similarity, we know that already, like cos of theta, and theta is basically a angle between these two vectors. And but to back, we have already discussed, like in deep learning we have continuous backup band and skip gram. Like what is, see about continuous backup band and skip gram, we can see that. And we have something like this, our ANN in loss function optimizers. We will, I think you will already know that, because I have done the deep learning playlist. So I think you have watched this project playlist. If you watch this playlist, you will easily able to understand all of these things. Like now we can understand what is continuous backup birds. So continue in continuous backup bird, what we have done, firstly at the time of training we have to decide like what is our window size. And window size is always basically odd number. So we have to decide like a 3 5 7 something like that. You can decide any number. This is basically a hyperparameter, basically a window size. Suppose you have defined a window size of 5, then you have to take two birds from right and two birds from left of that river. And basically middle one is basically we say that a model to predict this bird. So basically I neuron company related to, basically I neuron company is related to, so is basically we have to say a model to predict it. If we provide a I neuron company related to, then you have to predict it what is maybe the possible vector, like input is our this one and output is basically age. So this is something we have created our input and output. So like input basically a company is to data and output is related data science to, basically is related to data science. So that's how we have created input and output vector, so that our model will now able to understand each and every concept. Like why we are doing like in we are taking only between two predictors. So basically we have a problems in, basically we have done like RNN and LSTM model. We have seen that we have a problems of basically a context vector problem. Like if we are talking, suppose we are talking my name is Nancy Dangi and I am a like something is there, then how, like who I is referring, we can't able to understand. So to solve this problem we have introduced a CBAW, like continuous backup bird, so that we have provided initial and last bird, and basically we see that a middle one is you have to predict, so that our model is also know the context of the previous and uh, basically after, so that model will now able to understand all of this like previous and after, or basically so that it will perform very well. That's how we will train our model, so this will work very well. So after this what we have done, basically create we have done this one input and output is created now. So at the time of training we will pass all of this input by flattening the layer. So here you can see that the layer is to be flattened, like iNeuron is basically at the time of training we will fix this input size, so that every time we will pass this input vector to a same size. If this is not in the same, then we will apply some pre and post padding, so that our input will looks in the same size, so that this will work very well. If you have a not a vector to this dimension, then you have to do some posting, like pre padding and post padding, so that your model will not fail. Basically you we want, so iNeuron we can write is something like that 10000 and company is related to, and say that to our model if we pass this input, and here basically hidden layers, many hidden layers you can apply it, and say that output label looks like this. That's how you have to train this model. And output layer basically our sigmoid function is there, so like where the probability is very high we can say that yeah this is the output. Or we can apply also a backward propagation, so that the bit that the time of training will be initialized, basically the initialized, so according to that, so that the bits will be and bits and biases will be trained in such a manner that our model will get a good accuracy, or the basically error will be minimum as possible as can. Now this is done for continuous backup bird, and now we will see a skip gram. Yeah. So what is skip gram? Skip gram is basically opposite to continuous backup bird. Here we will say input is basically age and output is iNeuron company related to. Basically opposite to, basically we can say a CBAO, like continuous backup bird. Here also we have to decide a window size in a odd number, and according to that we can get like something like that. Related is like company is like opposite, we can say if we pass in input is this, and we will say yeah you have to pass this like output something like that, and apply here we apply a software function, activation function, and in between we will apply a relu, and many more functions are there. You this is depend on basically you, and this is a hyperparameter. Yeah, improve continuous backup bird on scriptgram, increase the training data. Yeah, increasing the window size, vector dimension is also increased. Yeah, increasing the window size, if you increase the window size, vector dimension is also increased. Yeah, so vector dimension, how this will increase, if you increase the window size, then your vector dimension is also increased. Yeah, So if we apply a 5 dimensional vector, then here you can see that only uh, basically we have given a unique number to that vector and create a basically one hot encoding vector to this iNeuron. But in real life, here we are only seeing. But in real life, if we see a but to back, but this is basically a bird embedding vector. Basically, with the ranges between -1 to 1, and this will be looks like different. But here to introduce, basically we are applying some constraints so that you can easily understand. When should we apply continuous back of bird and skip gram? So small data set, if you have a small data set, then you can apply continuous back of bird. If you have a huge data set, then we have to apply skip gram. Yeah, so that's it. Like in your mind it is coming like why we have to apply this continuous back of bird if we have a small data set. Yeah, so that basically if you have a small data set, so our input will be very huge. Here you can see that we are passing a 4 input and saying output will be 1. But if we have a huge data set, then we have an input again a small. Why we basically we are opposite the continuous backup, but so that's our output will be input and input will be output in skip gram. So our input will be a very small number, so that's why we have, if you have a huge data set, then we can say apply a skip gram. Now Google bird to back 3 billion bird Google news. Yeah, so basically we have already talked about like the Google bird to back model was trained on 3 billion birds. Google News feature representation of 300 dimensional vectors, cricket, like yeah. So every bird basically is represented in a 300 dimensional vector. Advantage is what is the sparsity matrix, dense matrix. The sparse matrix is there, but now it's converted into a dense matrix. So dense matrix basically we have a defined shape, and every time you have a three-dimensional vector, and this will be a very complex numbers are in between there. Semantic info is getting captured. Yeah, so like honest and good is in the space of vectors. This will be a very, the distance between these two vector honest and good is very small, so that our model can understand, yeah, these are like related words. If you find a cosine similarity between these two words, this will be a very small number. And vocabulary size will also increase in the fixed size set of dimension vectors. Google bird to back have 300 dimension, but nowadays we can see here 2480 dimensions. So basically birds are very, the English dictionary is very used. So now our model will creating a 2480 dimensions, so that a model will capture a good features. Out of vocabulary is also solved. Yeah, so now our problem in the previous model, like in basically one hot encoding we have seen, and what we have seen, one hot encoding, and what I've seen, TF-IDF, yeah, TF-IDF, bag of birds. You've seen here the problem is like out of vocabulary is there, but now in this bird embedding techniques, in this about vocabulary is not a problem. Like if you provide a bird, there will be a possibility is there, this will be available in your dictionary. If it is not available, it will create a unique vector basically, and then assign some values to this. Average bird to back is there. Yeah, so average bird to back is same as bird to back, but here what we have done, we basically we have firstly create a vector like bird embedding, and then take a summation according to this column, so that we, like if you have a uh, that time the, if you have a word the, and this will be represented in the 300 dimension, like some value is there, and this and food is also represented in 300 dimension. So basically we have to take for every values at index same, and add addition of all these value, and take divide by the number of uh, like words in this sentence, and then we will get a average, like it's same as average basically. And gensim globe is the package we can see inside a Python library. Here this all of these pretend Google bird to back model and train a bird to back from scratch. All of these pretend model are available inside a Genesim or globe model. And now see we are TensorFlow library. Inside our TensorFlow we have a Keras library, Basically we can say a keras is a wrapper on the TensorFlow nowadays. So all of this model like train a bird to back from scratch, you can train it your own bird to back model. If you train it, you will get a good accuracy. If you apply a bird to back Google, then maybe you will not get a good accuracy. We have to train our own bird to back model so that we can get a good accuracy. And this will all this pre-trained model is available inside a keras library, you can find it. So we will wind up this lecture. Yeah, so this is for the bird embedding. I think you can understand. Like now I will advise you like what is the use of bird embedding, all of this. So bird embedding is a technique to represent your English bird in a math in a similar way, so that if you provide a bird like happy or angry, then you can understand like, yeah, this is opposite bird. So in math you can also understand, if you provide a angry vector and a happy vector, our model will now able to understand it. Yeah, the distance of this two vector is very very far, so this is basically a opposite bird. So if you apply some calculation, a mathematical operation on that bird, and in English real life you will get a same answer in bird embeddings according to this basically applying a arithmetic operation, you will get a same answer. So that's why this is the powerful bird embedding. You can see that that's how this will work. That's it for today, guys. Let's meet in the next lecture for NLP. Yeah, thank you guys. Please subscribe my channel. I will create a content like this. थैंक यू गाइस, मिलते हैं नेक्स्ट लेक्चर में। जय हिंद, जय भारत।